Hi, Margaret.
Hello.
Welcome to.
Can you hear me now? Yeah, okay, my video's working. There we go.
Can hear you.
What softball does. Recording is on. Oh god.
Hi, Summer. Hi, Marcel. Make your camera go just a little bit to the left or right, one of the two, just a tiny bit. Almost there. Perfect. How are you guys doing? Good.
On Thursday, we have a game at 3, so I would assume that I'm going to have to miss the entirety of this period.
Oh, that's gonna suck.
So is this my last MS1 class, or do we meet on Monday?
Monday.
We do meet Monday? Okay.
Hey, Keith.
What's up?
How's it going?
Oh, going all right?
Good. Welcome to class, Max.
You?
Where is everybody? What the heck?
I know, right?
Am I clocking ahead? I got 2:15 right here.
I got 2:14 on my computer. So,
They got time.
what's the old phone saying? 2:14.
How do you change your name? Because
I don't know.
I'm using Louise's computer, and it said as a joke she can make my name whatever she wants if I can use her computer. And so she made this my name.
Ask epinephrine and aniline what they did.
Well, they somehow became hosts, too.
Well, I make them hosts. Oh, wait. Actually, aren't they presenters?
They're hosts.
Oh, I'm going to make them a presenter then.
Help. This is not me.
Can you guys see me in Adobe Connect? Because the window is not loading for me.
Yeah, we see you fine. Yep. So, Margaret, you're good.
Ramsey, how do you change your name?
Under the participants list drop-down menu right under Edit My Info.
Thank you.
Thank you.
There we go.
Yeah.
I had 2 papers due today, so I didn't get to chem problems, unfortunately.
Didn't you get to what?
I didn't get to as many of the chem
Alright.
problems as I would like.
Okay. Oh, I gotta make myself host again, because otherwise
You made yourself.
I just
host?
demoted myself and now I can't do anything.
Wait.
Alright, I'm gonna have to sign out and sign back in, because I was like, someone signed in as me! Let me try.
That's just like, how do you let...
Right, I think I've lost...
They probably shouldn't let that
Well,
be a possibility.
Yeah, but somehow, like, I can't go in and make myself anything else anymore. That's awkward. I may have to, let's see, I don't know how to do this. I may have to restart the meeting. What a knucklehead.
Mr. Walker just demoted.
I'll be back in a second.
Presenter, and now can't undo it.
Maybe somebody else could come in and take the reins.
Hey, Mr.
here.
Walker, I'm going to run surprise for
Don't go
tomorrow's talent
anywhere.
show.
Lost them.
Yeah, I know I'm the that, but I don't know. All right, I think I'm back, but I still don't know. Max is right. Maybe that didn't help anything at all in terms of. All right, let me try to go back in with this.
How do you demote yourself?
I don't know. I'm an idiot. I fired myself from leading the class.
Why don't you like have everyone leave the session and then restart the whole session? No, like to restart so you can like
I don't
post
know.
it.
'Cause I'm a knucklehead. I just fired myself. I thought someone had signed in as me, like you guys, like you like to do. Go ahead. And then I couldn't tell where I was, so I demoted myself from host to presenter.
Well, I wasn't even in class, so I don't know why you would assume it was something.
Oh, I'm
me.
back, baby. Full power.
Does that mean you reapplied to the job?
I don't know, I guess.
Why is my name in italics?
I don't know. My name was in italics, and I thought that means somebody signed in as me because I hadn't been paying attention.
Italics just means that that's who you are in the session. Italics doesn't really mean anything else other than that's who you are.
So if I'd have understood that, I wouldn't have demoted myself in the first place.
Yeah, Mr. Walker.
Yeah, Mr. Walker.
It's been like, what, 4 months?
Hey, how you doing, Peter?
Hey, Mr. Walker.
Welcome to class.
Thanks.
Since the way it's spelled, Peter, HDX11692630.
Let's see. Robin is somehow logged on, but I don't see him.
Else too? It's just Robin. Oh, we're just not on it, so it looks weird.
Who's your silly person?
It's me. Where's Kira today?
We need to
Kira's
drop back. Kira sent me an email, said she had an appointment and she'd be a little late, so she'll be here, but it's a little late. Robin, we can't see you. I don't know if you can hear us, man.
Can we play the height game at some point?
Yes, but maybe
You
not
told him about
today.
it? You told him about it?
Yeah.
It's a good game. All right.
I just don't want to miss it on Thursday.
So, looking at, it looks like people are logged in. Thank you. So there's some sad news. There are no more videos for you guys to watch. Well, there actually are, because I made videos for Chapter 8 if anyone wants to get...
Micro points.
We'll have to save that for Kira. Yeah, if you want to go on, you know how to find it on YouTube now. Just go crazy. So we're done with videos, and it's all about review now. Hopefully people are feeling well, and hopefully people maybe have some questions for me to go over for class about any of the homework problems or any of the questions from last year's test. And I've emailed the test off to your coordinators at your school, so you should be ready to take that tomorrow or Wednesday. And I hope that works well for your schedule. We have 2 more live classes. We have Thursday of this week and Monday of next week, and they're all about exam review. So come to class with questions about, how to prepare for the exam and what to do and what to study and all that good stuff. Margaret and then Max.
I was wondering, for the class on next Monday, I might be taking a final exam during this time. I'm not sure, and I was wondering if, since it's for review, is it absolutely mandatory to come?
Not a problem. Not a problem. It's for your benefit and not, I don't think it would hurt you either, so it'd be fine. Just make sure I'm clear about the format of the exam and what to expect by at least Thursday of this week. Peter?
Can I actually take my final next Monday?
Next Monday? Yeah, I think that's possible, yeah. Yeah, sure, you can do that. Just check with your school. Can they proctor it okay on Monday?
Yeah, they said it's fine.
Oh, that's great, Peter. Thanks for asking. And I'm happy to have you take that early and get it out of the way, so that's fine. And Young Hyun, so that's Peter would like to do that, and Young Hyun. I might do it, yeah.
Mr. Emerson.
Okay, yeah, that's totally fine with me. Thanks for
How long will
asking.
we have for the final exam?
Say more?
How long will we have for the final?
Yeah, it's written to be about 2 hours, so I don't, you could have more than that, but I don't think you'll need more than 2 hours.
If you study.
Yeah, it's so I think it's sort of like 2 tests in a sense in terms of the amount of time and material. So that's.
Are we going to talk about the format?
Yeah, we'll talk about the format. Max, do you still have a question?
Yeah, well, I mean, just because I'm not going to be here Thursday, I just had a few more basic things. Because I don't really remember exactly what chapters 1 and 2 were, but I remember them being more review.
Yeah, pretty much
stuff like that. Is that going to be stuff that's on there, or should we start reviewing from 3 to 7 as opposed to 1 and 2?
So Max is asking. He said chapters 1 and 2 are mostly review, and I think you'll find that to be true. So. There may be some stuff from chapters 1 and 2, like draw a Lewis dot structure, but probably by now you guys have been doing those so much that that's super easy. Or, like what's the formal charge of the carbons in this molecule. So as long as you remember some of those basics, you should be fine. Or what's the bond angle in this molecule, or what's the hybridization. So yes, hi Kara, welcome to class. There are some things that go back from chapter 1. But I think you'll find when you look back over that stuff seems especially easy now that you've been so much more complicated and difficult stuff. Young, go ahead.
Oh, I thought you said I was like, I'm not. Okay, so every single test we've had,
Change rooms.
Yeah.
Yeah, whoever's logged in as Pure Cocaine, change your name to something not that. I'm just clicking these things, but actually I should just kick you out of class. Thanks. All right, Peter, let's make you a presenter, and Young and presenter. All right, Young, go ahead. I interrupted
So
you.
like every single test we've had so far, it was like the beginning is like just these exercises that we like drill through, and then it like goes into these harder concept problems. Like, is the exam going to like have these really big problems that are like multi-parts, like from things taken from the chapter?
All right, good
Or, like,
question.
I don't know how the exam.
I'll say a quick thing about the exam right now. I think this is true. Every exam question that I'll ask will be in the back of one of the chapters. So in other words, it could be an even problem that we've already been assigned for homework, or it could be an odd problem that we weren't assigned, but we could have done for practice. So I think I can pretty much say with confidence that every question on the exam is from our book. I don't think there's an exception to that. I might make up like one, which would be something like give me 3 isomers of octane, and maybe it's not in the book, or something to that effect. But almost every question will be either a homework problem that you've already done, or one of the evens that you weren't assigned, but it would be almost identical to one you've done. So yeah, I don't want to try to come up with an exam question that's like super complex that tries to go over 3 different chapters at once, or ties it all together, in one big essay or whatever like that. So yeah, I want the exam to be fairly...
Are you talking about the final exam?
Yeah, I'm talking about the final, Kira.
Okay.
There are a couple people that are going to be absent either next Thursday this coming Thursday when we have class, or Monday, which is our last class. So I just wanted to mention the final just a little bit so that we were okay for that. Let's go on and talk about the test that we have. Any other questions before I go on? All right. Okay, so you guys have had a chance, hopefully, to now finish up any of the homework questions, the odds that were assigned, and maybe even some evens. You had a look at last year's test. How about some questions from you guys? And Robin, I can't see you. If you have a question, please text it in.
Last year for APK. Oh.
I'm going to type in Robin. Whoops. We can't see you.
I'm trying to put on the camera, but for some reason, I don't know, there's a technical issue.
Okay, so we can hear you. Yeah, we can hear you, but all we see is a cool looking weird blur of a blob for an image.
Weird.
When he speaks, it pops up.
Yeah, so it's good to know you're here. Kira, you've dropped off the screen. I don't know if that's just the way we're showing it or if you can't see us.
She left the meeting.
Oh, she left. Okay. She's probably logging in from home.
She was on her phone.
I got you. Got you. All right, how about who's got a question from the homework or wants to go over some stuff? Anybody?
Yeah, I have some questions.
Extra credit. Good. Go, Keith. What you got?
Do you have the test you sent us last year? Like, do you have it in front of you somewhere? Because there's questions about that.
Keith, you the man. Check it out. We got to load it up.
I'm gonna pull it up to you real quick. So.
All right, so which question?
Well, let me get it up.
All right, so yeah, I loaded up last year's test on here just so we could see it on the board. So we're all set for whatever question Keith has or anybody else.
Ready for anything.
I got some questions for you guys too.
Sorry, it's super slow internet down here.
That's okay.
Wow.
You did it.
I know, right? I've stopped doing that finally. I think.
After 4 months.
I know, really.
I'm just trying to make sure Young's still awake. Okay.
He's alert today. Anybody have a question for me?
I gave a couple classes for class. So
50,000 volts.
Yeah.
All right. I'll sing a song. Oh, good. Anything for that. Which one?
Okay. For number 6, just the SN1 and SN2 thing.
Yeah, that's a good one. Whoever wrote these questions was a genius. They're awesome.
Yeah, I was confused on part D. It's sped up by the increasing.
All right, let's try to help with number 6D. It says SN1 or SN2, what is sped by increasing the concentration of both the substrate and the nucleophile? Margaret.
Wouldn't that be SN2 because the intermediate stage is the one with like both bonds being broken and formed?
Yes, so good. Both things are present in the what's called the rate determining step, whereas it's concerted as the leaving group is leaving, the nucleophile is coming in, and increasing the concentration of either the nucleophile or the substrate will increase the rate of the reaction. Keith, does that help you?
Yeah, yeah.
Now, Keith,
I feel like I knew that. I don't know why I marked it when I was doing it.
No, that's okay. Let's ask the reverse of that question. What is sped by increasing the concentration of only the substrate and not the nucleophile? Which one would that be?
They're both still sped by just
Summer.
That'd be SN1.
That would be SN1. So, go ahead, Max.
Aren't they? They're both sped up. It's just SN1 is.
They'd be sped up. Not if you double this. Like if you double the concentration of the nucleophile and it's SN1, it's no effect.
No,
Yeah.
but I'm saying, but if you double the substrate,
it doubles the rate of the reaction. It would speed up either one. That's good. So it'd be but not doubling the nucleophile does not have an effect in SN1. All right, good question, Keith. Thank you, Peter.
Could you just go down and just say whether or not it's SN2 or 1?
Let's do it. Thanks, Peter. Let's do it. So A, occurs more readily for a primary haloalkane. Let's call on someone who wants it. Ramsey.
SN2.
That would be SN2. Good, because it's got to go through that inversion, and the less bulky the groups, the better off for SN2. Good. So the first one is A is SN2. B, occurs in one concerted step. Marcel?
SN2.
SN2, good. So the second one's also 2. 3, produces what's called a racemic mixture from a chiral substrate. Which one would that be? Who wants that one? Margaret.
Isn't that SN1 because you've got like the first mechanism and then it can attack from either side?
Right, good. You rip off that leaving group and it flips to planar and then it can come in from either side. Good.
Can I actually ask Miss World if she has tissue?
Sure. D is sped by, we just did D. E is sped by using polar solvents. Who wants that one? Keith. I'm sorry, just messed it up. Peter.
SN1?
SN1 is sped by using polar solvents. Good, because you form that positive intermediate that can then be stabilized. All right. Produces an intermediate carbocation. Who wants that one? Ramsey.
SN1.
SN1, good. G is less likely if there are big bulky groups attached to the carbon, which the leaving group is attached to. Summer.
Is that SN2?
Yes, that's right. Good. The nucleophile would get blocked by them, and it wouldn't have as easy a time getting in. And then finally, H. Blank is likely to occur if an allyl halide or a benzyl halide reacts. Complicated vocabulary words, Peter.
SN1?
SN1, because it forms that carbocation that then can be resonance stabilized if it's an allyl halide or a benzyl halide, because it'll be an allyl carbocation. All right, good. Thank you for asking that question, Keith. Who's got another question?
I got more if you want.
Good. I like it, Keith. Extra credit.
Microphone.
Right.
What's your next one?
Trying to look at it. Can we just do can we do 7, just B, and then I guess C would be really quick to do. I just want to know the answer for it.
Yeah, that'd be great. All right, let's look at 7. 7 says the reaction of 4-bromohexene, 2-hexene.
Actually, can we do A? Talk about A too. Yeah,
let's do all of 7. So let's draw out starting with a 2-hexene. 1, 2, 3, 4, 5, 6, 7. I'm hoping everybody can do this on their piece of paper. On carbon number 4, we put a bromine. Methanol is going to be coming in, CH3O. You really want to ignore the H because, at least for doing the substitution product, it says the reaction of 4-bromo-2-hexene with methanol is faster than the reaction of 3-bromo-hexane with methanol. So you want to draw out that. Hexane with a 3-bromo, 1, 2, 3. Okay, so if you draw those two out, let me work with you, Keith, on this one, and everybody, or does anyone want to help Keith out with the answer to A? Like, why would it be faster for methanol to come in and do a reaction with it than, say, with the 4-bromo-2-hexene than with 3-bromo-hexane?
I have an answer. I just don't know if it's right. I don't know if you want to say
well,
it.
Give us your answer, and Keith, Peter's got your back to see if you got it right. So you tell us an answer, and Peter, tell him if he got it right. Go.
The only really difference between the two compounds that were reacting was like the double bond on the third carbon or the second carbon. So I thought that the resonance stabilization may help. Is that anything on the right track? Yeah.
That is totally right. Oh, sorry, I wasn't supposed to say anything, was I? Peter, is he right?
I think you're right, Keith.
Right.
Yay! Good job. So when you pull the bromine off, you form a carbocation, and the first compound is resonance stabilized because the double bond can shift over one, and that helps stabilize it. But when you pull it off of the other one, all you got is a secondary carbocation that's not stabilized by anything. So
would we assume that that reaction tends to do SN1 more often than the other kinds of reactions?
If it's got that double bond C double bond O, right, C double bond C, sorry, one over from the leaving group, then the carbocation would be stabilized, and it's most likely going to go SN1, and you've got a good reason for it. So there's no difference for steric hindrance. Like if it were SN2 and there was the CH3O were coming in as the bromine were going off, there's really no difference in those two molecules. The double bond doesn't change that.
Right.
So the only thing it changes is stabilizing the carbocation. So that's why it's most likely SN1, and it's most likely resonance stabilized, just like you said.
Okay.
So let's go to the second question, which is B. Show the expected substitution product. Again, you're going to substitute on the top molecule, not the bottom molecule. So, Summer, do you want to take on the answer to that one?
No, actually, I had a question about the first part.
All right, go for it. What's your question?
I know that the first one is faster, but which carbon on the chain would it attack? Would it attack the one on the double bond next to the bromide?
No.
Or would it attack on the bromine, like where the bromine was?
Yeah, the bromine's going to leave, and the entering group's going to come right where it was.
Okay.
The nucleophile will come right where it was. I want to say one thing that could be different about that, but I don't want to make it too complex. You could potentially, since it goes SN1 and since it's resonance stabilized, your positive charge would actually bounce from carbon number 4 over to carbon number 2. So you could potentially see the ether form with the oxygen being where the bromine was, or it even could end up on carbon 2 and probably get about a nice mixture of the two because of the resonance. So I don't want to complicate things, and I wouldn't expect that necessarily as an answer, but that would be a true good answer. So let's go to B. Show the expected substitution product for the faster one. Who can give us that answer? Keith, go for it. Try it.
I've got it drawn on my paper here, so.
All right.
I can copy it to my board. I can copy it to my whiteboard real quick if you want.
Let's do it. Do it.
I don't know. Again, I'm not sure if this is right. That's why I'm asking the question.
That's okay. Hopefully everybody's trying this on their own, and assuming you haven't done it already. Thank you. Is that Margaret that's drawing those carbocations? Thank you. Good job on that. Yeah. And now you guys can just try to imagine methanol as being CH3O without the H, and then the O is going to pop on where that positive is. And take a second to draw that.
don't know if you'll be able to see this.
All right, let's try, Keith. Keith's going to switch his board for us.
Whoa.
All right. So that's what I got.
Zoom in just a tiny bit.
Why isn't he like growing bigger? He usually grows bigger when he talks.
This is actually as far as the camera goes. So.
Okay.
Yeah, I can't.
Do you still have a double bond between carbons 2 and 3? It looks like it, right?
Yeah, that's what I was sure. I don't know if that's still there or not.
That's correct, and you have an OC coming off on carbon number 4, right?
Yep.
You did it. Good job.
All right, sweet.
Oh, there we go.
Oh yeah, there it is. It shows up a lot better right when you went big. Maybe it finally recognized you as talking and being the major.
Yeah. All right.
Nice job. Again, this would be going a little bit beyond, but as Margaret's writing in, you could also, because of the resonance, you could also form that second compound that she's shown, and notice how her double bond is shifted over. And your positive would be now on carbon 2, so that's a really good answer to really be super complete. I would accept just the first answer, but the second one, adding them both, is actually the real answer. Who can name the generic name for this type of product?
Yeah, I just didn't know. I have no idea.
No, it's good. Peter.
Is it like an alkyl ether?
Yeah, I'll accept just an ether. Yeah, it's an ether.
Ether or.
Ether or, yeah.
Oh yeah.
Okay. I thought you were looking for like vinegar or something. It's like something in the store.
Yeah, nothing else. Nothing too complex. Generic name. All right, Peter.
Number 1D.
All right, let's go back to 1. Good, thank you.
I was mainly is the ethyl bromide the substrate, or?
So yeah, let's take a look at the question. And so you got ethyl bromide, so you got 2 carbons and then a bromine, or 1 bromoethane is more appropriate. And then you got an OH that's going to come in and react with it. And so the first thing says show the substitution reaction using push arrows, and then the second thing shows the elimination reaction using push arrows. And you guys will find that in the notes, at least something very similar to that. So if you want, we can go over it in class. But let's go to D. OH, the group that is coming in would be classified as the what? Who wants to fill in that blank?
Nucleophile.
Keith?
The nucleophile?
That's the nucleophile, good. The ethyl bromide, the group that's being attacked would be called the what? You said it, Keith, or Peter, a second ago.
Substrate.
The substrate, good. And bromide would be classified as the leaving group. Excellent. Good job. Thank you for that question. Yes, sir, go ahead.
And on the next question,
Number 2.
I forgot my alkene naming. Does it start from 1 on the left or the right?
What do people think about that one? Let's look at that one. Yeah, we should start on number 1 to give that double bond the smallest number we can.
Okay.
Maybe. I'm thinking.
I'd actually all the questions. Oh yeah, good point. So.
Yeah, that's why it's kind of. So yeah. So that's a what? 1, 2, 3, 4. 1, 2, 3, 4 chloro. Somebody want to make sure they can name that right? 4 chloro what?
1 pentene.
1 pentene.
1 pentene, good. You can't just put 1 pentene, or sorry, you can't just put pentene because you don't know where the double bond is. It could be on carbon 1, 2.
Oh, I thought we wrote the
No, I think you have to identify. Yeah, cyclohexane or cyclopentene, it would be implied, or it's got to be the lockdown position.
If that had how would you even write that? If it had 2 double bonds, would it be, well, like, I know it's supposed to be a diene, but like, how would you say that?
You tell the positions of it. So, say again.
Like 1,
1,3.
Yeah, it could be 1,3 pentadiene.
Oh, pentadiene. Okay, I just wasn't sure how to say that.
No. It's kind of weird how to say it, but yeah, that's how you say it. You say it just before the "ene," like diene or triene.
All right.
Good. Nice questions. How about, all right, good. Peter.
Number 5, B and C.
Great.
So is the better nucleophile just the one with more shells?
Yes, sir. So for C, that would be the first one, the methyl sulfide. It's got a bigger electron cloud. It's bigger and squishier, so that makes it a better nucleophile. And same for B, it would be the chlorine versus the fluorine. The chlorine's got more electron clouds. Yep. Big and squishy and negative is what you want for being a nucleophile. Yes, sir. One more time. Yes, you look for polarizability. Yes, for being a good nucleophile. All right, who's got another question? I know the hardest question on the test. No one's asked me about it yet, but that's okay. I'll wait. I'm sure there are lots of questions, so I'm just patiently waiting for more. Who's got another good question? Yeah, go ahead, Peter.
Number 8.
Yeah, let's do it. 8 is probably a good one. Not the hardest question on the test yet, but it's a good one. All right, so 8 says ethyl bromide or bromoethane can react with ethoxide, and that formula is given, in ethanol in part by an E2 mechanism. All right, so you want to think back to what the heck an E2 mechanism is. Is the reaction concerted? And you got to think about what the word concerted means. So there's a lot of vocabulary here. Why don't we start by writing out the formula of bromoethane or ethyl bromide? So and what we're reacting with is ethoxide. Now we're told this is going to be an elimination reaction. So hopefully that brings up something for you. Hi, Kira. Hopefully that brings up something for you that makes some sense to your brain. So, yeah, concerted means one step. So is E2 concerted? Is it a one-step mechanism? Anybody? I see Margaret shaking her head.
It occurs in one step.
Yeah, it occurs in one step. So I wanted to say nucleophile, but really have to say base because it's going to act as a base. As the base is going after the hydrogen, the bromine is going to be leaving, and the electron that was bonded to the hydrogen that's next to the bromine is going to be dropping down and forming a double bond. So yes is the answer to A. Which reagent concentrations affect the reaction rate? Since it's concerted and since both are present, which things affect the reaction rate? Anybody want to answer that one?
Both of them.
Both of them, good. So both being the ethoxide and the ethyl bromide, or the bromoethane, whichever you prefer. So both would be affect the rate. With which type of substitution reaction would this most likely compete? Since it's E2, what do we think the most likely reaction it's going to compete with will be? Yeah.
SN2?
SN2, yeah.
Is that always true, or is it?
I think for the most part. Also, it's a primary. The bromide is coming off a carbon that's a primary carbon.
Right.
So that is, again, most likely be SN2. So, yeah, but generally E2 and SN2 are going to compete most, and E1 and SN1 are going to compete the most.
Okay.
And all bets are off the... yeah, go ahead, Keith.
Ethoxide is the nucleophile here, right?
Ethoxide would be the nucleophile if this were a substitution, so yes. But since it's an elimination, we're actually going to call it something else.
Base.
A base. Good. Yeah.
It's just because they reverse it. Usually they say the nucleophile first, or so I got confused.
I know. Sorry, and that's the thing that makes it confusing because it can do both things. If it goes SN2, it's a nucleophile. In this case, we're going to want to think of it as a base. D. Would a strong base favor this reaction, or would it favor substitution?
This one.
This one, yep. Bases want to rip that proton off, the second proton over from the carbon that has the bromine. And then finally, E. The confirmation. Now you have to think kind of way back to, remember we had anti and ghost, but anti is when they're as far away from each other as possible. Anti-conformation of the hydrogen and the halogen atom is preferred for this reaction. Explain why. Trying to explain that clearly is a little on the complex side. Anyone want to take it on as Keith? Go ahead.
Yeah, I remember I asked this question in class one day. Just because I remember you told me like the electron flow is supposed to be going in one direction, kind of. So if you start from the farthest away, it'll all like be able to flow to the right without ever having to like have an interruption.
Good. There's one other thing in that they all have to be in the same plane, and Margaret looks like she's drawing it out for us. They all have to be in the plane so that the electrons that are dumping off the hydrogen into forming the double bond and the electrons that are dumping off onto the bromine, all of those have to line up in one plane for it to work as efficiently as possible, and only in that confirmation are they all lined up really well. And she's doing a great job of drawing in the plane of our board the hydrogen at the right, or it doesn't matter which, and the bromine all kind of have to line up like that, and the other groups, which are, in this case are just hydrogens, are in and out of the plane of the board. Woo! Good question. All right, thank you. Ramsey, go ahead.
So Kira's asked a question in chat, which is saying, what do you get in the exam?
Yeah, so Kira's asking a question. We're going to take a small sidetrack to answer, and then we'll come back. What do you get for the exam? You'll get a periodic table, an electronegativity chart. All those reactions you got back in Chapter 5 are given to you from the very beginning. So, like, it's just tons of reactions. Also, all those, like, benzene ring derivatives, things like aniline and all those other things, toluene, what they are. So I think everything I've given on every test as a possible aid is given on the exam, and nothing's ever given to you at one point or taken away at another or anything like that. So thanks, Kira. I hope that answers that question for you. And we'll talk a lot more specifically about the exam in the next class. All right, who's got another question, either about some of the homework problems or the test? Robin asked for number 14. All right, let's advance. Number 9 is a good one that we should make sure we do, so someone make sure we come back for this one. Number 11, I think, is maybe the hardest question on the test, just because all that stuff about whether it's SN1 or SN2 or E1 or E2 is all really complicated and difficult. So I think 11 is hard, but we're going to go on to, which one was it, 15? 14. That's what I said, 14? All right, let's look at 14 then. 14 says, what product is formed when the following compound reacts by SN1 with sodium cyanide? So we got a cyanide group is coming in to substitute. Bromide is going out. Why don't everybody try that real quickly right now, and then we'll give an answer. And Kira, we may have to get you to mute your mic because we're picking up background noise off of it. Thank you. So people try 14, and then we'll get someone to yell out an answer for us. Thanks for asking that one. Kira, we're going over question number 14 on last year's test. Okay, cool. And Robin, we can't see you, but we're hoping you're doing well.
Yeah.
And luckily chat's working, and yeah, we can hear you though. Thanks. Anybody think they're ready to answer 14?
I guess.
Young Hyun is. Anybody else?
I don't see what else.
Do you want us to draw the structure or name it or what?
I think we'd have a hard time naming it. Well, we could try. We'll just try to talk it through. But you could draw the structure too. All right, Young Hyun, does anyone want a little bit more time, or want to go ahead and answer it? 3, 2, 1. Young Hyun, give us an answer.
Well, just replace. I just put the C in where the BR is.
Yep, put the C in where the BR is. Would you put the C facing the C or the N facing the C if you had to line it up and bond it?
Would the C is facing?
C faces the C, yeah. So that would probably be called like 2-methyl-2-cyanide, or we don't know how to name that, so we're not too worried about it. But there's a C triple bond N, as Margaret's being awesome and drawing right there, and a lone pair off on that nitrogen. But that's our substitution product. This is sort of more a review question than anything relevant to this test. Is the compound that we started with optically active?
No.
No is the correct answer. If it had, instead of going down, say that carbon had 3 carbons instead of 1, would it be optically active?
Which carbon?
Say the carbon, the bottom carbon. So there's like a methyl-methyl-ethyl. What if it were methyl-propyl-ethyl, coming off? I know that's not how we'd name it, but then would it be optically active?
I don't believe so.
Yeah.
It would be, because that carbon would then have 4 different groups on it. It would have a methyl group, an ethyl group, and a propyl group, and a bromine group. Yeah.
You're right.
If that were the case, would it still be likely to go through SN1? Yes. And here's the trick question, or the final question. Would the product go from, let's say, R or S, or would the product be a racemic mixture of R and S? So just think, don't yell at an answer, but let's say it started off as R arbitrarily and it had 4 different groups on it. Would the final product, we're going SN1 now, would the final product be the inverse of that, go from R to S, or would it go to a racemic mixture? All right, that's enough time. Who wants to answer it? Go ahead, Peter.
Racemic.
Racemic! Good, because by SN1 we pull the bromine group off. Everything pops into a plane. There are 3 groups around the carbon. The cyanide can now come in from either side. Comes in from the right, let's say arbitrarily it forms R. Comes in from the left, arbitrarily it forms S. So you get a racemic mixture. If this is SN2, it's a different story, and it's not. But then the cyanide would come in as the bromine's leaving, and would invert like the umbrella, like Margaret said, and we'd go from R to S or S to R. Okay, but that's not what the question's asking. All right, who's got another question?
Was all the optically active stuff on this chapter?
No, it was a different chapter.
So is a question like that fair game for the chat?
A question like that is sort of fair in the sense that you do need to know that if it goes SN1, it inverts geometry, and you also need to know what the word racemic means, because it could be a 50-50 mix. So yeah, but again, that's good. I reviewed that for the exam, but I'm not going to go crazy on something like that on the test. Peter has another good question.
Number 9, 10, and 11.
Nice, good. 9 is a great question, and I really think our book is well designed in the way they ask this question. So let's look at it, and we really have to think to get the answer to this one. And this is, again, a question from our book. I'm not creative enough to come up with a good question like this. What E2 product? So we're going to go elimination, and we know we're going to do E2, so we've got to think about what that means. Remember, that's not popping the leaving group off and forming a carbocation, and then the thing comes in. It's a concerted dance so that the nucleophile is coming in just as the leaving group's leaving. What E2 product will result by the reaction of sodium ethoxide? Now, again, ignore the sodium. It's really an O with 2 carbons on it that's going to come in. And since it's elimination, is that O with 2 carbons coming in, is that going to act as a base or a nucleophile? Just take that for a second.
Base.
Good, it's going to act as a base. Then it's a question of which hydrogen it takes. Let me pull out my pointer for a second. We have 2 hydrogens that it could attack. It could attack here, and the reason I'm pointing here is because the hydrogens have to be a carbon 1 over from the bromine, or a hydrogen off here. Now, there's a hydrogen not shown. Since this one's up, or let's say this is arbitrarily up, there's a hydrogen going down, and since this bromine then is arbitrarily down, there's a hydrogen going up. And then off this carbon, there's a hydrogen, say, up and down, and off this carbon, up and down, up and down, up and down. But our hydrogen that's going to go away is either off this carbon over here, which we could call, I guess, carbon number 6, or it could be over here, which is carbon number 2, again, assuming this is carbon number 1. So you need to think for a second, and that it's E2 is really important. Do you guys remember what's special about E2 in terms of the way it has to line up? Yeah. Marcel, do you want to take this one? No? Okay. Who wants to try to take this one? Yan, go ahead. What? Good. The bromine and the leaving hydrogen have to be in the same plane. So let's just arbitrarily say that this bromine is going down. It needs a hydrogen next to it that's going straight up. Because let's say we make a conformation, and you have to remember your boat and stuff. Let me pull that arrow out of there because Margaret's trying to draw. SN2 also would it'd have to be planar too.
A good thing, like snakes on a plane, like SN.
Ooh, snakes on a plane, SN2. Snakes on a plane have to be lined up. As long as you can remember 2 for that, not 1. Why is it snakes on a plane 2 rather than snakes on a plane 1?
You gotta figure that part out.
Snakes on a plane, good. All right, excellent. So Margaret's done a great job of drawing all our hydrogens here. The other thing we'd have to do, I'm a horrible artist, so let me take over that. We also would have to kind of draw one of these guys, and I'm not going to be able to draw this well, especially given how fast I got to do it. Remember these things? The chair conformation, right?
Awkward chair.
Yeah, the awkward chair. So if we had a bromine coming down here, we'd need a hydrogen coming up here, let's say. And these guys would have to be in the same plane. So let me switch back to pointers for a second. Oops, I got to get rid of my pen. Go back to the pointer. So it turns out if our bromine is sitting, say, down here, we want our hydrogen to be up here. The problem with this ethyl group right here is it is sitting, if the bromine is straight down, the ethyl's sitting straight up. So it's blocking, and this hydrogen can't be the one that goes away. That means one of these hydrogens have to be the ones that go away. And where does our double bond end up when we're done? It ends up on position number, well, we'd have to start numbering. We form a cyclohexene with the ethyl group on carbon number 3. Let's see if we can draw that real quickly. What is going on? I know, right? Let me try to go to a bigger size here. Can I draw here? Wow, that's huge. Sorry, this is me with my big pencil. This is what the final product is going to be. We'd end up with a double bond here and our ethyl group here, like that. And the reason
I think you're using highlighter.
No,
I just used a really super fat pencil. I went a little excessive on the thickness of my line because I hate those thin lines, but I think I went a little bit overboard. Let me pull back here. I can also, well, that's the answer to the question, but let's make sure we understand it. The whoa, let go of that thing. Can I? No.
Pointer's trapped.
My pointer's trapped. Can someone move the pointer for me? There we go. Thank you. That was helpful. Do people understand why that hydrogen right there can't go away? Yeah. Someone's grabbing my. Stop it. All right, wait. All right. Someone else grab. Thank you. Why that hydrogen there can't go away? It's because if the bromine is straight down, the ethyl group's straight up, and that means the bromine and the hydrogen can't line up. So it's only the bromine and the hydrogen one over at the top of the molecule is shown that can go away, and that forces the double bond to go there. Somebody asked me if they don't get that, or if that's confusing, or if they need some more help with that.
It can't take the hydrogen that's attached to the ethyl, but it can react with the other hydrogens up top. Yeah. Or you're saying this won't work at all?
No, it will work with the other hydrogens because they can be in the chair conformation. They can be either axial or equatorial, and one of them has to be equatorial up since it's right beside an axial. Sorry, one can be axial up because it's right beside a bromine, which we're going to say is arbitrarily actually down. So it's definitely possible. There's a question very related to this that I could go to since we're right on the topic. So if you don't mind, I'm actually going to go there next, even though it's not the next one that Peter asked. Can I? I'm going to switch to another question on this same test. Can I go away from this slide? Here we go. We're going to go to this last question on the test here. And try this question for a second because it's essentially the same kind of thing. We're again going to go to E2 mechanism. And this is sort of leading you into it. And notice we've got a bromine that's going to be going away. We always look for our leaving group. So you're going to want to look and go, aha, there's my leaving group. Let's take a second and draw the other chair conformation of this. Now, again, it's been so long for us that I want to make sure I help you. So this carbon right here, which was down, all right, let me get rid of my pointer because I think Margaret and I are going after the same thing. Yeah, let me go back to my pointer for a second. This carbon right here that's pointing down, when the chair flips, is now going to be pointing up. So this hydrogen that was equatorial up is going to go axial up as Margaret's drawing. The ethyl group down here, which is kind of irrelevant to all the chemistry, is going to end up still down, but now axial down. So we could write ETH or ET ethyl group there. Let me get rid of the pointer.
I'm not drawing anything. I don't know.
So that's somebody else. Okay.
That was cute.
Okay. All right, I'm assuming it's you. If we take this point of the molecule, this guy's pointing up. When we flip it, this is going to be down. So our bromine that's here equatorial down is going to go axial down right here. So let me get somebody to see if we can, maybe I can try to quickly get in here and sneak in and do a BR real small right here. Sorry, not great with that. Now we're drawing that as being, what is that, axial down. Now let's take this hydrogen right here that's right now, let me point to it, get rid of this, sorry. This hydrogen right here is equatorial up. When we flip in the chair position, it's actually going to be right over here on this carbon. And what's it going to be? It's still going to be up, but it's going to be what up? Can someone name it for me?
Plane.
Nope, not the word we want.
Axial.
Axial up. Good. So I'm going to try to draw that up here right there real quickly. And draw the axial up hydrogen, and it's not, well done, but there it is sitting there. In this conformation, now notice the complexity here, though. It's really complex because, you got to flip the structure, but hopefully you can see. Can I go to highlighter, or let me go to green for a second. If we circle this hydrogen right here and this bromine right here, these are the two that are going to be eliminated and go away, and they're in a plane, and our double bond is going to form in between them. And there is a methyl group, as someone just wrote in there, thank you. And so, again, it's been a while since we've seen this, so I wanted to take a little time in case you were to see a question like this. B, the conformation you drew, which is off to the right, is favored for reasons of steric hindrance. It turns out it's better to have our ethyl group and our methyl group sitting out equatorial rather than axial like they were. All right, so that's just a statement. We don't actually bother us too much. Why is it the only conformation that allows the E2 mechanism? This gets into this chapter, the heart of this chapter. Why is this the only thing that allows for the E2 mechanism? Snakes on a plane. Yana just used your mnemonic. Should be proud of me. I know, definitely. Snakes on a plane. Margaret, go for it.
Okay, I thought I got this. Maybe I don't.
I think you do.
When you look at, where's my pen? At the structure that we drew, the plane with the bromine and the hydrogen that you circled, they're in the same plane. Whereas in the in the other structure here, I think one of the, was it the methyl group that's somehow in, yeah. I see that the H and the Br are in the same plane here. I don't know that I see how this Br and the CH3 are in the same plane and therefore pose some kind of problem.
So they're not in the same plane, but the bromine and the hydrogen have to be in the same plane. So on the left, there's never a structure. You can never have a structure with a bromine and equatorial where it's going to be in the same plane as a hydrogen, because that just doesn't work out. But if it's axial, it can be in the same plane with something. And it turns out on the right, just because it's done a ring flip, now the bromine is straight up and the hydrogen is straight up, or straight down and straight up, but they're now in the same plane, whereas before, you're right, they weren't. If you could look at them down the bond, they would be like 60 degrees from one another.
Okay, thanks.
Yep. Yeah, go ahead, Peter.
Sorry, but if this was E1, would the bromine or the hydrogen leave first?
Good question. If this were E1, the bromine pops off, and that leaves a carbocation, and then the entering the base can go after the proton that's sitting beside it and still make the turn into the C double bond C just like before. But the bromine, we say the bromine always leaves to form the carbocation either way. It's a good question. I see we're running out of time. We got about 5 minutes. Should I try to get to the other questions Peter had real quickly? Peter, what was the next one you had? I'm sorry. Oh, you know what we didn't deal with is this crazy hardest question on the test, I think. So let me do 11, no matter what people say, because, again, this is tough stuff here. Also, remember on a question like this, I can give partial credit. So you've got to guess if you're confused or just give the best answer you can. Okay. So realizing that this is difficult, let's take question 1. First of all, always analyze. We've got to decide if it's SN1 or SN2 or E1 or E2. The first thing we want to look at, someone needs to mute their mic because their noise is messing them with us. We look at the fact that this bromine is sitting on a primary carbon. So is that going to favor 1 or 2? 2. So that drops us down to only 2 possibilities. It's either SN2 or E2. Then we look to the right and we look at what kind of nucleophile or base. Is this a pretty good nucleophile? Nice, big, juicy sulfur with a negative charge. So that helps us say, hey, this is going to be substitution, and it's going to be SN2. So that's the best answer for this. And then for the, what is the actual product, rip the bromine off, stick the sulfur on, and you've got 1, 2, 3, 4 carbons, and then a sulfur, and then 2 more carbons. So that's the answer, and I'm not taking a lot of time with it, but again, I've got to get through these next 4 in a little bit of time. So that's the answer to that one. SN2, the final product, carbon, 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 then a sulfur, carbon, carbon, because that group has come in where the bromine's gone away. All right, let's look at the next one.
Can you just go over how did you get to the what you said about the primary carbocation or something?
Good. Look at this carbon right here. It's only got 1 other carbon attached to it.
Right.
So you go, wow, there's hardly any groups attached to it. That's almost definitely going to be, probably SN2 or E2.
Okay.
Because it's only got 1 group. Now contrast that with this one where we've got 3 groups stuck on. So it's definitely going to be either SN1 or E1. And then we look for elimination, we need a really good base. And ethanol, what do we think about ethanol as a base? Horrible base. So this one is definitely substitution, and it's SN1 this time because we form a tertiary carbocation. So this is SN1. Imagine the bromine's gone, just doesn't exist. What do we stick on instead of the bromine? What's the next atom?
Oxygen.
Oxygen, then C, then C. What happens to this hydrogen?
Goes away.
Goes away. Just get rid of it, pretend like it's not there. It actually goes over with the bromine, and it's part of the product, but it's not part of the product we care about. All right, for sake of time, let's keep going. Now we've got a secondary carbon. This is the hardest kind, meaning it could go all over the place. And given Max is saying it's got to be E, he looks over and sees we got a really super good base right here. This is an excellent base, a strong base. So it's definitely elimination. Okay, it's not substitution. Now we would accept E1 or E2 as an answer. Go ahead. What?
Wouldn't it also be a strong nucleophile?
It's an okay nucleophile because it's negative, but it's nowhere as good as that sulfur right there. Okay? So you're right. No, you're right. It is a pretty good. It's a pretty good nucleophile, but it's not the best nucleophile you could find. Like that sulfur with a -1, that's a sweet nucleophile. Or a cyanide is a super sweet nucleophile. But an oxide like that is actually a better base than it is a nucleophile. Go ahead.
But like, how can you just determine that it's a better base than a nucleophile?
You kind of have to have it memorized almost. You just have to remember, if you see ethoxide or methoxide, those guys think super strong base. Because honestly, Peter, what it's coming from is methanol and ethanol, and they are horrible acids. They're awful acids. They don't want to give up their proton. That's a strong bond there, and so it makes it a super strong base, either methoxide or ethoxide. That's the one thing to memorize, if you will, going into the test, that this is a super strong base.
In one of the videos, he has it in one of the videos explaining the trends of increasing nucleophilicity or increasing basicity.
Okay.
I think it's in 7.4 or 5.
And we're running out of time, so I'd accept either E1 or E2. Since it's a secondary, you really are, it's going to be hard-pressed to know, and I'd give you credit on either one of those. So I don't want to spend a lot of time on that, which is good news for us. The last one is again, you want to look at the leaving group, and it's got 3 things on it. So
isn't that the same one?
It does look like the same one.
It just says D this time.
I think I did a horrible cut and paste there. That's exact. Is it? Oh no, it's not the same one. Sorry, it's very, very, very close.
Oh wait, this just.
But now we still got a strong base, but now we're going to push it more towards E1 or E2. Which way we're going to push it this way?
E1.
E1. So you'd expect elimination 1. The only other thing we didn't take the time to do is what the elimination products are. So don't forget, you got to form a double bond. Unfortunately, we're out of time. People can email me if they have questions. Good luck. Thursday's class and the Monday after that is review for exam. You're going to take the last test for me on either tomorrow or the next day. See you guys. Robin, sorry we didn't get to see you.
We saw him for
Next. I just take a math. It's not good.
Don't forget to end the meeting.
And what is the locker?
Locker number. Thank you very much, Mr. Walker.
Thank you, Robin. Take care.
Bye. Thank you.
Bye. We're going to hang up on those dudes.